Hey, good morning. Welcome to
MinuteMath number 152.
MinuteMath number 152. This is an awesome problem from the Mathematical Association of America's MinuteMath page, and actually this is one of my favorite problems ever from these old contests. This is actually an AMC 10 problem, so this is a problem for 10th graders. And only about a third of them got it right. You ready?
Yep.
The positive integers a, b, a minus b, and a plus b are all prime numbers. What is their sum? So I modified the problem a little bit, but This is really what they're asking. So what do you have to know about to be able to solve this problem?
You have to find what A and B are.
Okay. And what else do you have to know about?
Prime numbers.
Okay, what are prime numbers?
They're numbers who are only divisible by 1 and the same number.
1 and the same number. Is 1 a prime number?
No, by definition.
By definition, no. 1 is not a prime number. Okay, and what are some properties? Well, tell me what some prime numbers are.
Well, like...
Here, start writing over here.
There's like 2, 5, 13, 19.
Okay. It's not all of them, but that's in a start. What can you tell me, what's a property that most prime numbers have? Maybe not all of them, but
Most primes are odd.
Most primes are odd.
Except for this one.
Except for 2 is the only prime number that's not odd. Okay. Alright, so that's a hint on how to think about this problem.
If A equals 5 and B equals 2, A minus B would equal 3. And A plus B would equal 7. They're all prime numbers. Is there more than one solution, though?
Well, that's an interesting thing. Okay, so what is the sum here?
The sum is, it's 17.
Okay, so we found one where the sum is 17. Now the question that you're asking, which is exactly the right question, is there another solution to this problem?
Well, you can't switch these around. That wouldn't produce a good answer because it would be negative.
It would have negative, and so it says they're all positive, which is important.
So we could do. Well, maybe we could do if A equals 5 and B equals 7.
Okay, that's a good one to check. A equals 5, B equals 7. Well, how about, since we're subtracting B away, let's do A equals 7.
Okay, yeah.
And B equals 5. Okay? So the important thing here is that they're both odd. Okay, what happens? What's A minus B?
A minus B is 2.
Okay, so that works.
And A plus B is 12.
Is 12 prime?
No.
Why not?
It's divisible by 6 and 3 and 4.
Okay.
And 2.
And 2. It's even. So if A and B are both odd, what happens to A minus B and A plus B?
One of them is even. Actually, all of them are even.
They're both even. An odd minus an odd is an even, and an odd plus an odd is an even.
So you have to have a 2.
So you get 2 even numbers. If these are both odd, you get 2 even numbers. And can two distinct even numbers both be prime?
No.
No, only one of them can be prime. So one of these numbers A has to be 2, which is what you did up there. And so you found a solution that works. So there you go. That's the answer.
Okay.
Awesome. That's a good problem. That's a really neat problem.